Hey, hi everyone. Let's start. Today we will talk about AI agents. We have about 1 hour to discuss AI agents, and it will be quite technical. So I will show you some code and we'll discuss technical aspects of agentic AI. So my name is Nikolai. I'm founder and CEO of Hyperskill and Advancium. So we build platforms and products for learning. And nowadays we use AI a lot to enhance learning and also to teach people AI skills. And also I'm a member of Sunday Club, which is a AI hacker group from MIT and Harvard. What exactly is an AI agent? This is very broad term and like very new. So it's still undefined, and different people mean different things when they are talking about AI agent or agentic AI. But there are two main views or two main qualities of AI agents. The first one is that it's AI systems that are more complex and go beyond a single prompt. So if you're building some software with and call AI like OpenAI LLM, for example, if it's a single prompt, it's just for regular AI. If it's like multiple prompts or like complex prompts orchestration, it means it's an agentic system. And the second point of view is that it's AI systems capable of operating independently of humans or controlling your device. For example, OpenAI Operator is one example of this agentic tool. We will mostly talk about the first one because actually the second definition highly depends on the first one. So you cannot build AI system to operate independently of humans if the system is not complex or go beyond the system, single prompt. So what we will talk about today is mostly how to build larger, more reliable products and systems which use AI, in particular generative AI. So we will, like, by AI we mean generative AI here, like large language models, for example. Yeah, we will discuss complex systems, how to build them, like what frameworks are, like what are best practices, and so on. These systems can then deploy it to operate independently or like control device or operate like dependently of humans. It doesn't matter much. It's mostly like independent operation is more of a function of how accurate your AI system is and how good your AI system is. So if it's very good compared to humans, it can do more independently. If it like its quality is not so good, it will not be able to operate independently. So basically, a second one requires the first one, and we will talk about the first one today. Basic building block for agentic AI, agentic network is we will call it augmented LLM. So it's large language model or just like a prompt and call to like API call, for example, to large language model. But this model or this call is augmented by tools, memory, and sometimes retrieval. So tools are similar to what we human have when we operate. So LLM is similar to brain, like operate, like thinking, like brain, and tools are what we can use to make like our actions. For example, AI agents can search like online, internet, some information, and search can be a tool for AI to perform its action. We will discuss tools, and I will show you some tools later. And another important part is memory, because large language models are stateless and they can process data. So there's the input tokens, the output tokens, but they don't have a memory as we are, I guess, as humans are. So memory is quite important to build AI apps and especially agentic apps. And this memory can be anything, like it can be like a variable in your code which store some value, or it can be a database, or it can be like different types. Like there are different types of databases. Oops. So this is memory, and retrieval is so it's how to say, it's not like a separate one here actually. So it can be like a tool, like retrieval tool from memory, so you can retrieve some information. But it's a separate here because it's quite well known and widespread pattern of RAGs, where you retrieve some information from somewhere, like from internet, from your database, from your documentation, like whatever, and you augment your prompt with this information. So this is RAG, and a lot of agentic implementations, agentic networks are using RAG. So the retrieval is is drawn here separately. I also highly recommend you Anthropic article about building effective agents. I think many illustrations which I will show you today is from this article, but if you want to dive deeper to agentic, like patterns, agentic, how to build it, agentic software, I recommend you to read this article in full. So what agents are? Usually it's some LLM call or like augmented LLM call, which can take actions on environment and get a feedback. So this is about operating independently of humans, but also environment can be something like not very complicated. So not like it's not required for AI to, you know, be a robot and go outside to do something. Like AI can actually like act on a website or create a file or something like that. So it's usually a loop of some actions and feedback until we reach our until we complete our task. So agents are the same as just single prompt, but should complete the task better, like with a better quality, like less hallucinations, like more reliable and so on. So it's about making AI apps more like smarter, actually smarter than a single prompt, I would say. So the same as we humans use tools, memory, like whatever we can use to make actions, the same for AI. We can build AI apps to use same stuff to execute tasks better. And this is an example of high-level flow of coding agent. So, for example, we have a human UI, like interface of ID, let's say, LLM, which is processing our request, and some environment, for example, file system with code files. And human ask in interface some query, like do something like code some app. And while until task is clear, human and LLM are trying to clarify what exactly a human needs through the interface. And when task is clarified, interface is sending like additional context if it has it. And then LLM is working with file system to build whatever human wants, like search files, like return process, like write tests, write code, and like run code sometimes, depending on the mode. And yeah, so LLM is basically iterating with files, like your code files, until, for example, this task, which was given by a human, is implemented. And then, yeah, LLM says that it's complete and interface displays it to human. This is an example of coding agent, which use LLM, which it probably has some like tools to write code, to like run code, and so on. And it definitely has a memory and environment with memory as a file system. And this is one more picture of what agent is. So we already talked about tools and memory. And here are some examples of tools. For example, by the way, one of the common tools is calculator, because as you probably know, LLM is very bad at math. So like LLM usually cannot like compute large, I don't know, kind of like multiply large numbers, for example. Same as humans, like we cannot, in our brain, we usually are bad at math if we are not using additional tools or memory. Like we can use, like, I don't know, a piece of paper to like write down an equation and compute it, but it's also memory, like for us, like external memory, instead of doing it in our head. So yeah, calculator just calculate some formula is one of the tools. Calendar, like code interpreter. So for code interpreter, also LLMs are not good at doing like executing algorithmic calculations, the same as humans. So we are not good at, I don't know, executing like complex algorithms in our head. So agent, like AI agent LLM, can use code execution. So agent can write code like human can write code. But then we have tools to execute this code, which is like, I don't know, Python. The same as human can like write code and execute code with Python. AI LLM agent can write code and then execute it with Python, for example. And yeah, there are like many tools, and there are like libraries with tools available for you to use. As for memory, there are two types of memory: short-term and long-term. So short-term is your state of your variables in your program, and it's short-term in terms of like every execution, like it's different. And long-term is databases. You can store something in databases and files wherever you need. But also one of regular patterns we see in agentic systems is planning. Since LLMs are not like good at solving complex problem, same as humans, like if we have very complex problem to solve just with our brain or even with tools and memory, it's sometimes very hard. So we use planning and AI, so humans are using planning, and also we built AI systems with planning. So first, like we can plan, like have chain of thought out, like, or just plan the complex task, how to execute it, and then break it down into subtasks and execute each subtask separately. So planning helps. It's still a question whether we will need as complex like planning as it is now for LLMs, because reasoning models are getting better and better. And sometimes like you can solve quite a complex task with a reasoning model nowadays, and you could not do it like just a year ago with regular models. But it's still quite a common pattern to use reasoning, like more expensive, slower model, AI model, to plan how the task should be executed, and then use faster, cheaper, less intelligent, like regular models, LLM models, but smaller ones, to execute on a subtask. So you you basically apply higher intelligence to planning and lower, cheaper, faster intelligence to acting on this plan. And yeah, action. So action is quite important. Usually like agents are using tools to act on environment, on like any other, like between agents. So also agents sometimes are built in multiple. So like there are multiple agents talking with each other or interacting with each other. So agents are using tools to make actions. So this is a basic framework on what we call AI agents, and it's like there is nothing very, I don't know, innovative here. So it's mostly terminology to talk about AI systems, complex AI systems, and discuss them like with each other. So if your team is building like some agentic pipeline, it's easier to discuss having like the same terminology about agents. And everything I'm describing here, I will show you later on a few frameworks to build agentic systems, but you can implement them in any like programming language in any any way you want. So it's mostly like, agents are abstraction on top of simpler regular AI like prompting, just prompting. So it's agents are abstraction on top of prompting to build, discuss, and scale more complex AI applications and AI pipelines. Also, one note, as for tools, sometimes tools are, people call them function calling, because for agents, it's basically like agents are calling a function. So tools are sometimes, in some models and some products, are named function calling. So about popular frameworks, three most like popular frameworks to build agentic agentic pipelines, agentic apps are LangGraph from LangChain. So LangChain is a very popular framework to interact with AI and so on. And LangGraph is a abstraction on top of LangChain to build agentic graphs. Actually, like it's graph of interactions of different agents, where each agent is basically a prompt. Two other frameworks, CrewAI and AutoGen, are more like they're more opinionated. So LangGraph is lower level, so you control more, but like what you are building. And CrewAI and AutoGen, you specify, like more declaratively specify agents, and all right. Specify agents, their like roles, their like kind of input and output and so on. And then, for example, in CrewAI, you have a crew of agents, and then they kick off and like do this task for you, for example. So they can discuss something with each other, they can take action, like they take turns in actions and so on. So LangGraph is more imperative, more like straightforward, like it's more transparent, like what's going on. CrewAI is more abstract. It's like usually like you need to specify like smaller number of rules, like, and interactions, like you cannot always control. You can sometimes, but you cannot always control interactions between different sub agents prompts. But it's more like higher level. And for AutoGen, it's similar to CrewAI. It recently divided into AutoGen and AG2. So original founders of AutoGen decided that they don't. So AutoGen is mostly maintained by Microsoft nowadays, but the original founders, they decided to fork AutoGen into AG2. They're similar as for now. Maybe they will be slightly different in the future. It's not sure. It's still not sure which one should we pick in the long term. But you can go with AutoGen, for example. It's the main, like most people are still using AutoGen, not AG2. As for tools, most popular tools and are search, code execution, web browsing. Also, I mentioned calculator before. And search is just like online search. Like we humans can use Google to search information for us. AI agents can use search to find information they need. And for memory, people are using like in-memory state variables, using conventional databases like Postgre, and vector databases. Vector databases, like Chroma, for example, are good to store embeddings. If you don't know, embeddings is this kind of representation of information which store meaning like of this information. So, for example, if you have a large text, you can chunk it into multiple chunks, break it into chunks, and store in vector database. And you can search by not by exact like substrings and so on, but by meaning. So you can find like close like sentences close to your query by by human understanding, with conventional like regular human language words. So vector database, yeah, often used, for example, for RAG to augment prompts, augment queries to LLMs. Okay. Do we have questions? If you have questions, please post them here on Zoom, and I will answer them. And I will keep answering them along the way. So I will show you a few demos, but if you have questions, please post them. We'll have one question about hyperscale courses. I will answer it at the end. I will have something about it. So since we have no questions about this one, I will show you a few agentic patterns which are quite popular. So the one is it's kind of like same as we have design patterns like singletons or factory or facade or something like that. AI systems can have these patterns, and people who are building agentic systems came up with some common patterns. So it's easier to discuss ideas. It's easier like to implement and abstract on like multiple levels. So, for example, prompt chaining is obvious pattern where you have multiple prompts, multiple LM calls, and you, for example, have a like you call AI once, then based on output, you either exit your program. I don't know if it doesn't work, for example, or you pass the prompt to another one, and you chain basically output of one LLM call as an input to another LLM call. It's also good if you have a complex task and you break down it into subtask, and each LLM call is more focused on a single like subtask. It can execute it better, but then like you need to chain output into another LLM call. We have a question about, could you please elaborate on how CrewAI agents interact with each other? I will show you a demo of CrewAI, and I will explain it there. So it's basically, so they basically have like a chat between each other within a crew, and they can use each other's input and output to do their own tasks. But I will show you later. So next pattern is routing. It's also quite common. So for example, if you have some input from human, for example, and asking your system some question. For example, it's asking like some learning question about some topic, and you can have separate prompts, separate LLM calls for example, for math, I don't know, history, biology, and each of these LLM calls have prompts and maybe tools which are focused on some specific subject, and this router will route the question to the LLM call, which is best suited to solve this, to give answer on this query. For example, like math expert can have calculator tool, and like math knowledge and history expert can have like lots of history, like books in the database, and biology can also have some like biology related knowledge, or like, yeah, any like resources or tools or whatever. So this is routing, and it's also quite straightforward. Parallelization also one of common patterns where you break down tasks into few parallel tasks, and then you aggregate the result. And you can use it to break down your larger task into some independent subtasks to just execute it faster, for example, because like, you can execute them in parallel, and LLMs are sometimes slow, and to make it faster, can make parallel calls. Also, one of the common patterns is to do the same, basically, LLM calls, but with a higher temperature. So, for example, if you want to write an article like with AI, you can write 5 articles or 3 articles, like here on the screenshot. You can write 3 articles, and then you can, in aggregator, you can aggregate them, or you can pick the best one, or you can do something similar, because AI is like hallucinating sometimes it's not producing good results, and so on. To make it more robust, you can make multiple similar AI calls in parallel, and then pick one or aggregate a result on a later stage. Yeah, I have a question. What is the tool you use to draw these mind maps? These mind maps are from Anthropic article I'm showing you, and here's a link at the bottom. I'm not sure what tools have they used. Yeah, I'm not sure. But they're nice. I do agree. Yeah. So the next workflow is orchestration. It's kind of combination of what we had like in router and aggregation, but you can orchestrate your task to multiple LLMs and then synthesize them, the same as like you aggregate here. So it's kind of similar. So aggregator and synthesizer is somewhat similar, but yeah, it's quite common abstraction where you have some complex task, like for example, orchestration can either pick one LLM or have some planning and pick few of these LLMs, pass the subtasks to to these prompts, and then synthesizer can come up with a final result. The good question actually about the previous slide, can an aggregator distinguish between hallucinated output? This is a great question. There are some techniques to do it. And also, like technically, I'm not sure about API, but technically you can get a probability of the next token. So you can, when you get the output from LLM, you can understand how sure LLM was about this answer, but it's mostly token by token, so that not about the whole answer. The good actually good technique people are using sometimes, and I'm also using it sometimes. It's actually ask LLM about how sure it is. So like how confident. And sometimes, well, LLM can also hallucinate in it, but LLM can give you an estimate, like just with a prompt. So ask LLM like, please give me this answer and your confidence in this answer. And it will, like this confidence number, it's not like completely true, but it helps to distinguish between LLMs who are not like who are not so sure about their answers, or like answers from LLMs. Also, in agentic systems, you can use different LLMs. You can use ChatGPT, like GPT, Claude, DeepSeek. Like you can use multiple LLMs. And aggregator, for example, if it's a simple, like if not it's not simple task, but simple answer. So if you have like a simple answer, I don't know how many people are living on Earth or something like something else, all these LLM calls will produce you an answer, and aggregator can get like the answer where majority of LLMs agree. For example, if one LLM hallucinates, or if one LLM like don't know this, maybe like aggregator will just discard its answer. So there are multiple there are multiple techniques to reduce hallucination. Also, the funniest technique, which is so straightforward and simple, but it works, is in your prompts, you can add, like at the end, or just like wherever you want, don't hallucinate, or like don't make up your answer. And it actually helps, because if by default AI tries to answer any question, even if it doesn't like know the answer, like a student on exam, for example, they're trying to answer you, like answer a question, exam question, with whatever knowledge they have, instead of saying like I don't know, because maybe they will, like, their answer will be true, maybe not, but it's better than saying don't know. The same LLMs are trying to answer your prompts always, but if you say like don't hallucinate, if you don't know the answer, write I don't know the answer, something like that, LLMs will be like more accurate and will tell you when they're not sure. Okay, let's go to the next question. One question was, can we get this presentation? Yes, we will send this recording and presentation, I think, at the end of the webinar to those who attended. Okay, I've already told about orchestration, and the common pattern, also one of the common patterns, is Evaluator optimizer. What I showed you before is sequential. So everything here was like transforming input to output sequentially. But it's very common also to see some cycles in the graph of agents. For example, it's quite common in writing, in like customer support, AI systems, and so on. For example, if customers send you some ticket, like support ticket with a question, first LLM call can write an answer, like try to find solution, for example, to a customer's problem. And then the second LLM can evaluate whether this solution actually answers this problem, whether it follows company guidelines of like tone of voice, like whatever support agents should do. And for example, if it doesn't look like a good answer, it doesn't follow any like some guidelines, it can reject, give a feedback. So LLM generators then try to figure out the next solution, like by incorporating this feedback. So it's a quite common pattern where you split like task execution and task like evaluation editing. It's also similar to like some human structures. For example, you can have a team lead and and the person in the team. So person in the team do some work, I don't know, like write some code or write some article, like depending on what this team do. And then the team lead, like manager, supervisor, can evaluate like whether this person or AI have done like a good job by the solution. If not, they reject it and give a feedback, and this person tries again. So it's quite common pattern in human structures and also in AI agentic pipelines. And most of these patterns you can. So while you're implementing agentic AI, you can think about how we humans would implement like organization structure, team structure to implement the same task. And AI is usually like have lower intelligence, like lower cognitive abilities than humans. So you also, to build AI system, you need to make tasks smaller, more focused than for humans. But overall structure and idea is similar. You're breaking down like a large complex task into subtasks and agents who can complete the subtasks more like with more focused knowledge, with more focused tools. We have a question. LLM generator, LLM evaluator. Is it different models like both GPT-4o, different GPT-4o DeepSeek? What is the best to mitigate the bias? This is a great question. Sometimes people are using different models for this exactly to mitigate the bias. And also like generator sometimes has lower intelligence. So for example, this can be like 4o or 4 mini, and evaluator can be like a reasoning model, for example, like O1. Or it can be different models. So for example, we can have GPT here and Claude Sonnet here, or DeepSeek, or it also helps to mitigate bias, definitely, and mitigate, like use additionally. So for example, Claude is better at writing, so you can sometimes you can write with Claude. Because Claude is better at writing, so you can like write your solution. If it's like solution is an article, for example, you can write solution with Claude, but you can evaluate it with GPT. Yeah, so it depends on your task. People are using different models within like a same agentic system. Okay, we have questions. Yeah, I think I answered all questions along the way. So please post more questions if you have. And I have a couple of questions here, which I will address further. And I will show you a demo. So I will show you some code. Let's try of LangChain and CrewAI agents. I hope you can see it. Make it larger. Maybe I can. Good idea. Okay, let's try to make it. So this is a sample LangChain code with with some imports, with OpenAI key. I'm using GPT-4 mini here and in all all other demos. But yeah, you can use any kind of model. And this script has two tools. One is calculator, which basically with Python evaluate any expression. So if LLMs want to compute something, it may use this calculator. And also we have a search tool, which is DuckDuckGo from LangChain. I use DuckDuckGo here because it doesn't require any API key, but usually people are using Google SERP tool. So this will be an agentic graph to answer any more complex questions using search and using calculator. So I will show you it, and then we will query it with some questions which can be answered using like online web search and calculations. But before, we have agent state, so it's a memory. It's just in memory state memory, so it's in RAM, and we have 3 agents. I will show you visualization here. So this is a graph of a LangGraph, and LangGraph, basically by writing LangGraph agentic code, you are building this graph. So this is also was visualized with a LangGraph function. So human will start with some query, and planner will decide whether it needs to execute some tools, and executor have search and calculator tool. So actually, like it's written search here, but it's both search and calculator. And executor can execute these tools and provide the answer to planner. And while planner like is replanning and executing tools, they cycle like between each other. And when planner has enough information to answer the question, it goes to like a final answer agent who formulate a final answer based on initial user query. So instead of using a single prompt to answer the user query, we have a planning stage, and we can use online search and calculations. And this is a planner. So, and this is a planner's prompt, like your planning agent that decides which tool to use. It can use search, calculator, or finish. So basically, it's simple like routing what to do next. Then we have executor agent. Given the conversation, what should we use the tool name for? So if planner decide to use search or calculator, this executor formulate like a query to search or exact like expression to a calculator and uses this tool. So it use so generate the input for this tool and like here, tool input, and then it executes the tool. So it just like invoke the calculator or invoke search tool. And final answer is a simple agent. It just given the whole history of conversation between these agents, it formulate a final answer. And we are building graph with nodes and edges between these nodes, which I showed you before. So this is a graph we actually built. And in LangGraph, you need to specify this connection. So you need to specify this logic, like what agent is connected to what agent, like what tools should they use, like what routing rules are, and so on. So it's lower level than CrewAI, for example, but it's more controllable. It's easier to understand what's going on here. It's easier to control, but you need to do more. And I will show you how it works for this query and maybe like another queries. So yeah, where is it? So I ask like, what is the population of Tokyo multiplied by 2 and invoke this graph with this query. And you can see, I will show you from the start. So I asked what is the population, then planning agent. This is a prompt from planning agent, which since it's a prompt, it's considered like human message in LangChain output, but it's agent. And then this agent decided that we need to use search. Then search, executor decided that we need to search for this, like what is the current population of Tokyo. And using DuckDuckGo search, we found some information about it and passed it back to planner. Then planner decides that like need to use calculator. Then calculator agent decides that we need to calculate this amount, and using calculator, it did calculate this amount. Then planner agent decided that we have enough information and we can finish. And final answer is, yeah, this one, the population of Tokyo multiplied by 2 is 47 million. But yeah, we can do this. What's the population of a moon divided by 100, divided by 1, yeah, that's 10. Let's do 10. I don't know what is population of moon, but let's, oops. Maybe it will be 0, I don't know. So yeah, so what's the population of moon using search tool? Yeah, so the final answer was moon doesn't have permanent population, therefore population by moon is 0. And actually it used, yeah, it used search, but I didn't find anything. Yeah, it's interesting. I can try to do it again. But maybe it found that it's 0. Yeah, it didn't show up as like what's the population of moon, but it came up with a relatively direct answer. Okay, we have a few questions here. What frameworks for automatic agents evaluation do you use? Something like LangFuse. How to create this kind of pipelines? How do you log results? So we do use LangFuse. Also, LangChain and LangGraph have, I think, LangSmith for it. I haven't used it, but we use LangFuse, and it's quite convenient. It looks like everything, and it's easier to understand like what's going on. Agents with abstraction layers like LangGraph or without pure function calls. Pros and cons in your opinion. So all these frameworks are making easier to build larger systems. So you can build everything just in pure Python with pure, yeah, like LM calls, function calls, and so on. But yeah, first I preferred LangChain. Nowadays I prefer CrewAI because I want to write less code and I want framework to do more job for me. But it depends on how complex system you need. So yes, there is no single answer. For small prototypes, like you can use CrewAI. It's faster, easier. Yeah. Agent system latency, how to speed up process of agents getting us results. So you can use parallelization. You can use faster models. So for example, here I use Foro Mini, which is fast. So it's both cheap and fast. So you need to use like smarter, slower models when the task is hard. But for example, you can break the task into subtasks with smaller model and then use fast model for yeah, for each subtask. Also, there are some fast inference like Grok, for example, or Cerebrus. They usually have llamas, but with like really fast. And if you're building like a large agentic system, you can try to use Grok. Grok, not the Twitter Grok, but another Grok, which is fast inference company. Yeah, but it's always a trade-off between intelligence and like complicated agentic system and speed. So things are getting better and better every day. So nowadays, like models are smarter and faster than it was a year ago. So in the long term, I think speed is not an issue for most of systems, and you don't need to optimize speed much, because if you build a agentic system and even if you do nothing, it will become faster with the new model releases, and it will become better with new model releases, because new models will be like smarter, faster, cheaper, and so on. Okay, I will answer a few more questions later, but I want to show you CrewAI. CrewAI. So CrewAI is kind of similar to LangGraph, but more abstract. So I also have calculator tool and search tool, and for search tool I use the same actually search tool from LangChain. So CrewAI is can also like use LangChain, and you can use like lots of tools which are available in LangChain community package. But for Crew, you need to specify agents with roles. Usually like have goals and backstory. So this is a researcher. So it's not a specific prompt, but it's more like a person, like persona for this agent. And this is like a researcher agent. It can find accurate information on internet, like using search tool. And we have calculator agent, which can perform calculations using calculator tool. We have coordinator, who coordinate like research and calculation to answer the user questions, similar to planner in LangGraph example. And we have tasks. So we have research task. We need to research some information. To provide answer, we have calculation task, and we have final answer task. So provide a final answer. And actually, like final answer here will be provided by coordinator, not a separate agent. So we have 3 agents: researcher, calculator, and coordinator. And based on these agents and tasks, we are forming Crew. So it has agents, it has tasks, and we have a query from the user: what's the population of Tokyo? Oops, let's keep Tokyo for now. And we have research crew, and we give our query to this crew and kick it off. And let's see how it will execute it. So crew execution, it started, like researcher started searching internet. It found the same information as in LangGraph example. And then actually, interesting enough, a researcher figured out that it can multiply by 2 without a calculator, I think. But so researcher not only found the information but calculated it, because multiplying by 2 is relatively easy for LLM. But calculator, yeah, is trying to calculate it. Yeah, it's like this expression based on the previous like information from the researcher, and calculator also calculated this result, and coordinator, given all this conversation before, yeah, provided the final answer, that the population is 74 million. So we can maybe try find the moon population. So researcher, yeah, goes to internet, try to find like a moon population, yeah, and also yeah, come up with an answer. This is maybe it's too easy, because researcher figured out this answer by itself. But you can give more complex queries to them. Yeah, and this is the final answer. So this was a LangChain and CrewAI demos. You can use any of these libraries. CrewAI, have a crew and more declarative agents with roles, and you have a crew of them and they interact with each other. While LangChain has you need like to specify this interaction like as a graph. Okay, and let's. We will send you this slide, so you will have these links. I recommend you to also read through like this article about building effective agents and prompting techniques. And I also wanted to say that we have in Hyperskill, we have two opportunities for you. The one is a long, more comprehensive program, AI engineering bootcamp, which is, I think, 8 months. It will start at the end of March. Like next cohort will start at the end of March. It's usually like, I think the previous one started in February. And you can join this cohort using this promo code with some discount. So it's for people who are like a little bit technical, or technical, but want to become AI engineers. So engineers who use AI to build pipelines I showed you, or like complex AI systems to leverage AI as a building block in this AI systems. And it's a intensive program, so you need to be fully committed. It's 8 months long program. And also this Thursday, we will have a hands-on workshop to our workshop as a continuation of this webinar. So if you want to like try like hands-on, like different, like solve different agentic like problems, I will give you assignments during this workshop. You will build like a LangGraph, CrewAI, and AutoGen pipelines. You will like discuss them. I will give you feedback. So we will have a small group. It's not free, so you can sign up and pay using this link. Also, we have a $15 off for this webinar attendees promo code, but it will be 2 hour, very practical. So today I mostly like describe you what and show you what AI agents are, but to really understand and use them, you usually like need to be able to try it by yourself. And this workshop will be a guided practice of trying and building AI agents. And you need to be comfortable like with some Python and AI basics to fully participate in this workshop. And we have a few more questions, which I will answer. And yeah, I think I showed one question is, could you please elaborate on how CrewAI agents interact with each other? I think I showed you in a demo. It was a little bit fast, but they basically form a crew, and you can specify some connections, but overall they can like see this like discussion. Also, the very first question was what courses on Hyperskill are worth taking for AI ML. So I recommend you actually like this is a bootcamp based on a Hyperskill course, but and we are like improving Hyperskill AI like content based on this cohort. But yeah, right now the most up to date is these programs, and also we will. I think we already have it in, but maybe it's in a private beta course on like Agentic AI on Hyperskill. Okay, I answer this one. And agents' level of independence, how we can allow to be agents to so independent. Let's say we need somehow control agents and not blindly believe in matrix multiplications. Well, that's a good question. Yeah, well, it's a good question. It's kind of philosophical question. We should not blindly believe LLMs, but we need to build systems where, like, if some task is too complicated for LLM, or we see like a lot of errors, we need to like add more planning stages, or like more control, like evaluation of the results and so on. So building agentic systems are similar to building human organizations. Humans are also not perfect. They not always multiply matrices correctly. So if your human organization depends on like correct matrix multiplications, you need like humans who can do it, and also like calculators and so on. So the same for AI systems. But in general, since LLMs are less deterministic than regular software, you should expect that your agentic, like pipeline agentic software, will produce like results, like undeterministic results, but based on your industry, like it may be okay, or it may not be okay. In this case, you need to build more checks and like verifications and so on. Yeah, but it's a trade-off, and it's also an open question how to build. Well, it's the same question of how to build better software. Like sometimes we create bugs, like we need to control quality of software, but if we like spend too much time on it, it's too much effort, like we will not build anything. So lots of software do have bugs, but they're not critical. Same for LLMs. Like some LLMs will hallucinate, some answers will be incorrect, but our job is to make the system to solve tasks we need to be solved reliably. It can be like with like required level of reliability, let's say. Yeah, but there are more and more independent and autonomous AI agents, and yeah, I think like we will see much more this year and the next years. In the next question, in CrewAI, are all agents using the same model, just given separate roles? Is it possible to have agents from multiple models work together? Yes, it's possible. I use the same model just for this demo, like this LLM, but you can pass any model to any agent. So you can have different agents using different models, and that's completely fine. Yeah, and about autonomy, I will not explain you, but I wanted to show you there is a browser use package, which in Python, which basically runs LLM in your browser. And for example, you can give tasks like visit Python and tell me what's on the homepage. And this is an example of independently, like more like independently operating agent. Oh, it opened browser on a different screen. So it opens this browser, and it like looks at the browser, looks at like what's in the browser, analyzing with LLM. So it's let me show you. Yeah, so it opened the browser, like evaluated what's there, and when I go to my homepage, so it, I don't know why it stopped. Okay, yeah, maybe because I moved this from my another screen. Yeah, so it's navigating, trying to extract some information, and it takes more time. I don't know why. But basically, it's an example of tool. Actually, browser use, you can use like headless without like real browser, but it's example of a tool for AI to operate independently. Oh yeah, it did something. So it parsed the web page using LLM, and then it will probably produce a result. So it's, yeah, sees this browser with, yeah, that's completed, and it showed me the result of this page. And you can do more complicated query with this tool and with other tools. Okay, I think that's it for today. We're a little bit late. Thank you, everybody. Thank you for joining. I hope it was useful for you. Please join me this Thursday on a webinar. But it's not free, it's paid. But I hope it will be useful for you, maybe for some of you. And we will practice more with agentic pipelines, and you will need to build something, so it will be hands-on and practical. And if you're very serious about AI engineering, join our 8 months long bootcamp. It's hard, but it might worth it. It might worth your time. Thank you. Have a great rest of the day, evening, morning, depending on where you are. Bye-bye.